About a year ago, I wrote this tool to analyze Chrome extensions for security issues. I'll demo the tool real quick, and then we'll talk about why I wrote it, some of the challenges with writing a security tool, and some of the problems with just Chrome extensions in general. So first, let's say this is a Chrome extension. We want to analyze Hello Kitty cursor. So first you need the Chrome extension ID, and you can get that from the URL bar here. And you copy that and just paste it into the tool. The tool is at CRXaminer.tech. It's an open source web app. And you click Analyze. We'll go into the details later of what exactly the issues are and how it analyzes. Basically, an extension that's supposed to change your cursor is requesting permissions for storage. We can see in the manifest storage and scripting, which seem unnecessary. It works on all websites. So definitely a risky extension. I want to go into some of the details first of why I even wrote this tool and some of the security issues with Chrome extensions in general. First, pointed to an extension ID, and it goes and fetches the extension itself from the Chrome Web Store. It also scrapes for some metrics from the web store itself. For example, the number of users and the rating, those it just scrapes from the web store, like basically from here, because those are not available in the Chrome extension file itself. And then it extracts the file. So basically, the CRX file, which is the format of the Chrome extensions, it's just a header followed by a zip file. So you can just unzip a Chrome extension and look at the contents. And usually when you unzip a Chrome extension, this is kind of what the contents look like. You have a few files to host assets and images, and then you have the Manifest.json, which is where the permissions are defined, and it looks something like that. Now, if you're wondering what do permissions means, they're kind of self-explanatory. There is basically a web page here by the Chrome developer site that lists the permissions and what they do. For example, it can have access to your clipboard. It can have access to downloads. Basically, depends on the context of what each extension is trying to do. Like, why is Hello Kitty cursor trying to access downloads or something like that? So that's the first thing that the web app does. Is it's a Ruby on Rails web app, so there's basically a Ruby script that fetches extension, unzips it, then it looks at the permissions, lists potentially sensitive permissions or risky permissions, does some basic greps, and then displays the findings. And this is where the finding list here comes from. This is what it found based on the permissions. Then in details, there's URLs that are hard-coded in the extension, and that's basically through a grep. And then the manifest.json file, it's listed in its entirety here. So you can like look at the full manifest.json here. So why did I write this? Chrome extensions are risky in general. There is actually this really good blog post by my friend John Tuckner from Secure Annex. Well, basically, once you start talking about Chrome extensions, he just appears and starts talking to you about Chrome extensions, and he's very knowledgeable about it. And so he once found this website that is basically a marketplace for Chrome extensions. And I thought that was interesting. I asked him, like, okay, like, is it fake? Like, can you actually buy extensions from this marketplace? And so he tried it, and he did. He bought an extension. So he found one extension listed there that had basically network permissions over all hosts, and he emailed them. And you can read this blog post. It's very interesting in detail. But basically emailed them like, hey, like can I buy this extension? Then they tried to buy it for $50. They couldn't accept payment, so the person just gave him the extension. Like, here, have it. I don't. So I had downloaded this extension to test, but I didn't, like, I just downloaded it and just forgot about it. Like, I wasn't doing anything about it. I was monitoring it. And so there was an ownership transfer from the original author to John. And then, so now he owned this extension, and he basically pushed an update. The update added this rule. Basically, it's a network rule. Whenever someone's trying to visit secureannex.com, which is John's website, it redirects you to this URL. Anyone who's been in security long enough knows that this YouTube code is for the Rickroll video. It's a good survival skill to learn that by heart. And so he told me, like, visit this website, and it worked. It just redirected me to the Rickroll video, which means that he has control over my browser because of that extension. Now, on my end, nothing indicated there was an ownership transfer or any change from my end. So I was just normally using my browser, and it auto-updated that extension and changed the behavior of my browser, essentially. Now, in this case, my friend bought the extension. There was this other tweet from last year where someone was bragging that they bought a popular Chrome extension, 400,000 users, which means they had now control over the browsers of 400,000 users with the permissions of that extension. Now, in this case, this person is bragging about it, so likely not malicious, but that means the malicious actor could just buy a popular extension and just not say anything, and then now they have access to many browsers. Now, browsers are important. We do a lot of sensitive operations in our browsers, like banking. So I'm gonna go through a few examples of high-profile incidents involving Chrome extensions. So one of them is the Honey Chrome extension. So that lets you find coupons for discounts. And so people found that Honey was maliciously changing the affiliate codes from websites to their own so that they basically make money from it. This is unethical. Many people were surprised, like, oh, Chrome extensions can do that. Now, a spicier case was Cyberhaven's compromise last year. So this is a very, very interesting incident. Cyberhaven is a DLP company, which means data loss prevention. That is essentially corporate spyware. Basically, when you work at the company, if they want to find what you're doing on your computer, they want to make sure you're not like just exfiltrating company data to your personal Gmail. You're not like sending yourself 10,000 social security numbers. They install DLP software. Now, the way this one works is by installing a Chrome extension so that they can monitor what you're doing on your browser. I will say Cyberhaven handled it well. They quickly acted, detected the issue, remediated it, and had like a pretty transparent post on what happened. Basically, they got phished. So on December 24th of 2024, they got this email saying like, hey, we're about to remove your Chrome extension from the web store. This is worth panicking for them because that's one of their main lines of business. They want to make sure the Chrome extension is not removed from the store. So when they click, it goes to a legitimate Google site. It wasn't like an obscure URL. It was actually hosted on Google, where a third-party Google app requested access to their extension with permissions to update, edit, and publish the extension on their web store account. So this was basically a malicious third-party app on Google. They fell for that phishing campaign. They go into details on what the malicious change to their extension did, but basically it collected cookies, mostly targeting Facebook for business. I assume it's for ad fraud. Basically, the actors wanted Facebook business accounts that handle ads, maybe to resell ads and publish them at no cost for them. I'm not exactly sure. But obviously, they could have requested anything. So this Chrome extension had access to everything on all websites in your browser. So they could have done way more damage. In this case, it was limited to Facebook business account cookies that they exfiltrated. Which is another interesting thing about Chrome extensions. Some of you might think, oh, like what if you have an HTTP only flag on your session cookies? Would that mitigate the risk here? And no, like essentially Chrome extensions have God mode over your browser. So they can manipulate cookies even if they have HTTP only flags. And then the last example here is this a blog post by Pulse Drive on the Rylide info stealer. So essentially, I really like this example because it's malware. So you download either an exe or a PowerShell script. And given that the attacker is running either PowerShell or an exe on your machine, they can do whatever they want. They have access to your machine, given that they can run whatever they want, they choose to load a Chrome extension into your browser. And that is because they know the access that the Chrome extension gives them is even better than just running an exe on your machine. So the blog post goes into more details. It even lists some of the permissions that this extension has. Here, it basically requests many permissions: cookies, storage, active tabs, clipboard, very excessive permissions. So it has access to everything on your browser. Interesting thing is it poses as Google Drive. So it looks like you just installed a Google Drive extension, which makes it harder to detect. Now that my website has been up for about a year, I added the statistics tab here. You can see some recent scans. So far, over 17,000 unique extensions have been scanned. And you can basically sort them. You can look at the critical only if you're interested in that. Now, what are the findings given that over 17,000 extensions were scanned? So the first issue I noticed was that by default, I had way too many critical severity rated extensions. Now, perhaps it's because of my own bias. As I was making the web app, I was thinking about how risky extensions were. And the initial ranking system basically counted the number of findings based on permissions. And so, for example, if you had over 3 high findings, you would rank it as critical. Too many extensions were critical. And when you have a security tool that ranks everything as high or critical, that is not useful. And imagine you're using like a network scanner like Tenable, or even a static analysis scanner like SemGrep, and everything was being rated as critical all the time. You wouldn't really use it anymore, because you just know if you're going to scan something new, it's going to rate it as critical. So what's the point of scanning anything? I wanted it to be more meaningful, for the output to be more meaningful. So the first thing I did was I wanted to add some context. One example was EFF's Privacy Badger extension. It was initially listed as critical. Now, I trust the EFF. I know that it's a trusted publisher, so it should be a bit less severe than critical. So my initial approach was I used the Claude API, and that's what you see here. This top section, context-aware verdict. What my app does is basically it takes all of the files and manifest file, some of the data of the Chrome extension, and it takes my own findings, and it sends all of that into the Claude API. And we can see the prompt here. Basically, I use Claude Sonnet, and I give it this prompt. It's not very prescriptive on how I want it to rank the severity. I just basically ask it like, hey, like just take into consideration things like the reputation of the publisher and rank the severity of this finding. Let us know how risky it is to use this Chrome extension and give us some recommendations. And here's an example of the output. For an extension that just wants to manipulate your cursor, why does it need access to storage or injecting scripts? It seems risky, so it gave it a rating of high. Now, did that improve over the initial risk ratings that I had? Kind of. So initially, there was a lot of criticals and highs, and after the AI, so on the left side is before AI, on the right side is after I added the Claude ratings. And so basically what it did is it significantly reduced the number of critical severity rated extensions, but most of them, it just moved them to high severity instead. And for some reason, it also reduced the number of minimals, moving them elsewhere. Maybe because it just realized that there's no such thing as a minimal severity Chrome extension. All of them have some sort of risk posed. So does it actually help? I'm not sure. I do slightly prefer the risk ratings with AI, especially that it gives you a nice blurb here that you can copy paste and send it to someone that's less technical, and it gives you some more context. I would say that the general output is more useful given the Claude output. But then it made me think, like, how should we ideally be ranking risk for security tools in general? And this doesn't apply only to Chrome extension risk. Like, you could be writing a SAS tool, static analysis, for, like, looking at code or infrastructure scanning. All of those tools kind of have the same problem. How should you output your findings and present them to the user so that they're actually actionable and meaningful? Critical, high, medium, low is fine, but then you have the problem of, like, too many criticals. Some tools output CVSS. I strongly dislike that. You still have the problem of, like, many things are just CVSS 10 or 9 or 8. You're supposed to apply the context on how it affects your own environment. Many people do not. They just use the initial rating. I was thinking is if something like this works, where you have the output of a tool is either risky or not risky or acceptable. And then for each one, how much effort do I need to mitigate the risk? Does it take significant effort to actually mitigate the risk, or is it just a quick fix? And so the idea is that the output of the tool is helping me prioritize and determining what should I actually fix. The focus should be on the actual fixes and how can I mitigate and address the risk, rather than just enumerating risk overall. And part of the problem that this tries to help with is that when you have too many scanning tools and you're just, like, enumerating risk over and over, you have multiple scans running every day, you just have a growing backlog of risk. So you just have, like, more and more findings, 100,000, 200,000 findings at a time. Nothing's getting done. How do I prioritize them? It's very hard. So with this model here, it kind of emphasizes on, like, what actually should I fix? So if something is really difficult to fix and is very risky, maybe you should block it. Maybe you should actually spend a lot of effort to fix it. Maybe you should find alternatives to not use it at all. But basically take an action immediately, and it's going to be severe action, maybe including blocking. Now, blocking should be minimal, as in, like, you should try to avoid blocking as much as possible. Depends on your risk acceptance levels. Depends on your own risk tolerance for each company. Now, if it's easy to fix, just fix it. Just fix it now, immediately. If it's not very risky and easy to fix, it's nice to plan to fix it down the line, maybe backlog it. Now, if it's not very risky and it takes a huge effort to fix, generally that's not worth fixing. So you can just accept the risk. Again, it depends on your own risk tolerance for each company. Now, some of the general details of how I wrote this web app. So it is open source. You can check the GitHub, but essentially it's a Ruby on Rails app hosted on Heroku. Why is it Ruby on Rails? Why did it host on Heroku? It doesn't matter. I just happen to have experience with Ruby on Rails because I worked at some companies that dealt with it, and I find it easy enough to ship web apps with it. And Heroku also very easy to deploy because I don't have to think about infrastructure. I just hook it up to my GitHub, and when I push changes, it just auto deploys the changes into production. So I don't have to worry about infrastructure. I just push to GitHub and that's it. Now, one interesting thing is using the Claude Code API is not free. I'm using my own API key dedicated to this web app. So over the last year or so, for over 17,000 Chrome extension, it costs $114. Now, this is more scans than, so I list 17,000 unique extensions scanned, but many of them were scanned multiple times. So it's more than 17,000 scans. But assuming it's like, one scan per extension, then the price would be about this much for each extension scanned. It's not bad for the use case of Chrome extensions because 17,000 is not that much, so that's acceptable. Now, if you were writing a web app where you would have to do like thousands of these per day, then this does not scale very well. If you have the amount of traffic or amount of scans where you might be using 17,000 scans per day, then it's costing you this much per day. That's not very scalable, right? Overall, for my use case, it's acceptable. And the way I limit the cost as much as I can was by setting max tokens to 400, which essentially keeps the size of the output relatively small and consistent. Now, in conclusion, overall, there is risk around Chrome extensions. I feel like there should be more awareness around the risk of Chrome extensions. Many people just install any Chrome extension without really thinking about the permissions that they're asking or the risk around it. Now, there is a solid mitigation, which is to use different Chrome profiles. So in Chrome, you can set up different profiles, and the profiles are isolated from each other. So if you install a risky Chrome extension in one profile, you can just make sure that you never open your bank accounts in that profile, and so that isolates the Chrome extension from your sensitive data. Pretty solid mitigation there. Around 15% of all of the extensions I scanned had access to all URLs. Now, some of them obviously do need that, but that does seem excessive to me. In general, the permissions model in Google Chrome for extensions isn't granular enough, and it doesn't seem like they're incentivizing extension developers to just ask for the minimum permissions necessary. And also, when you look at the Chrome Web Store, it's not even clear what permissions it's asking and if it's necessary. Like, they minimize a lot of the information displayed, which can be good, but also does not really communicate risk around some of these extensions. I would hope that they have more alerting and more warning messages around excessive risk. I would hope that they incentivize or review existing extensions to always ask for less permissions. It's not easy to do, especially at that scale. Outside of Chrome extensions, for security vendors or anyone writing a security tool, I would like to start moving away from just critical high, medium severity output of findings and contextualizing some of the findings more so that they're focusing on remediation and prioritization from the perspective of those consuming the output. It does feel like some AI added context can help with this. Overall, from your perspective, yeah, use this tool, CRXaminer.tech. If you have feedback, happy to hear it.